welcome back to my YouTube channel. My name is Vignajit, and today we're going to talk about the solar system, and technically not the solar system, but the creator and the holder of the solar system. But don't worry, I will be going through a preview today about just the sun, and my next video I'll be going through a preview of the next planet, and the next planet, and on and on and on until we finish the entire universe. So I thought, why don't we make a preview? So I made this thing for you guys. So let's start. I think you can see the one right over here. And like the start, we're going to talk about the sun. And yes, it is a very big topic, but today I'm going to short it down for you guys so you guys can understand it well. 1. The sun's properties. The sun is the star that holds the entire solar system together and also gives light and to the perfectly close and habitable planets. It also supports life. Just imagine how a hard job that is. Today, we're going to talk about the sun's properties. So basically, the sun is the source of the solar system, heat, light, and without the solar system, we'll be suffering in the cold, and all the plants and animals would die because obviously they also rely on the heat of the sun. Because usually, if you're planting something outside, don't you always put it in the sunny area so it gets the energy? Because the sun gives off a lot of energy. So this number 2 is going to be a long one, so you guys should pay attention to this. Number 2, the sun's layers. The sun has layers just like the planets. So now we're going to talk about the layer. We're going to go through the layers. From the topmost layer to the corona layer. Is the most hot-like atmosphere that protects the sun from outer space objects. So instead of moving on, I want to give you a small, what it is. This is the sun, okay? I made it black for a reason so you can see what the corona is. So this is the sun right here, this black thing. And then around it is an atmosphere like other planets have, but this atmosphere is way hotter, denser, and holds the sun into one entire ball. So that's the corona layer. Next one, the second of part 2 is the chromosphere. This is a very interesting topic interesting layer because a lot happens down here. So for the next layer of the next layer is the chromosphere, and the importance of the chromosphere is that it keeps the sun intact, or else the parts of the sun except the core will be flying everywhere throughout the solar system. So the chromosphere would keep the sun intact, and that is very important. So guys, every day you see the sun, but you don't really see the sun because it's way too bright for your eyes to take it. But everybody knows that the sun's round. And how's it round? The chromospheres. The chromosphere keeps it intact, keeps it like a good and neat sphere. But if the chromosphere wasn't there, you would never be experiencing night. I mean, you would, but the night would be so energetical that you can't even sleep. It starts to energizing your joints, and it just starts. The sun's energy just flies everywhere. You know, it doesn't stay in one place. So quickly, would lose a lot of light, a lot of heat, and the sun's lifetime would be gone in a poof for a year or two. So yeah, that's good, but because the sun's intact and using the right amount of fuel at the right time, it could be going for another 3 to 4 to 6 more billion years. That's a lot of time for us. And part 3 of number 2. The next layer is the photosphere. This is also very important. The next layer is the photosphere. The importance of the photosphere is there's no photosphere when we have no light, because the photosphere makes light safe and healthy to let off in the solar system. So this will be a bit confusing, so I'll tell you guys. If there's no photosphere, we would not be getting light in the way we do every morning. It'll be like a solar flare booming onto the earth. So the photosphere also slows down the light with lower plasma. It sucks out its plasma and lets out a type, the sun technically doesn't give off light sometimes. It gives off really hot energy, and the photosphere filters it and gives off only the light energy to leave the plasma energy with the sun so it doesn't waste all its fuel at once. So that's the photosphere importance. And I know these layers of the sun are very much different than all the plants' layers because the sun isn't really that solid. It's covered in plasma, air, energy, and everything. So things are able to go right through it if it had the right protection to go right through it, or else it'll be burnt to a crisp. Part 4 of the sun's layers. So this is basically what a preview of the last 2 or 3. Yeah, I'll see. The next 2 layers we're going to talk about is the convective zone, radiative zone, and why the convective zone is so important is because all the plasma is hidden and packed together tightly so the sun could recycle and heat the fuel. And the importance of the radiative zone is that, like a garbage truck, it uses up all the plasma, is shot out of outer space. And we call that a solar flare because it uses up all the energy, and the sun's only radiative zone could do that because it's perfectly near the core and the corona. So now I'm going to explain to you. I didn't really say it that fast, but I'll explain to you. Like we said in this one, the 2 next layers were convective zone. And why the convective zone is because all the plasma is hidden and packed together tightly. So let's look back at this picture. Do you see the convective zone here? Right here is where all the plasma is running around. But the convective zone pushes the plasma together to filter its energy and give it straight to the sun's core so it can start using it, or else the sun would run out like a poof either. It can't get its energy. The core can't just go around the planet to get its energy. There has to be something pushing all the fuel toward the core so it's usable. And the radiative zone is a very, very important zone, just like the photosphere. The radiative zone is a zone where all the the radiative zone is like we're all like between the convective zone, like at the start of the convective zone and the so on next to the core, and it's perfectly in the middle of the sun's layers. And that means And that means that if there's no radiative zone, all the energy would be poofing if the sun was massive. But if it was very small, it would not let out its energy at all, and in just a few hundred or million years, it would just like supernova or just nova. And yeah, so that's how it goes. But radiative zone has an importance. It pushes in all the usable fuel and recycles it, and after you can't recycle it anymore, the radiative zone lets out a hole in the through all the layers and then pushes all of that energy out that hole like a solar flare. That's what we call it, the solar flare. Like right over here, solar flare. It makes a zone and then pushes all the energy out of it. That's why if you're standing next to a radiative place in the earth, in the sun, because one place the radiative zone explodes, it'll keep exploding there. And and one side gets so dense and that side explodes, it'll just keep exploding there. So if you guys possibly got on the sun and you're near a radiative zone, be ready with a jetpack because it'll boost you off very far. So yeah, that's a convective zone and radiative zone, the most 2 important zones. And I'm pretty sure the photosphere is pretty much important than these 2, but we'll see. 3, we finally moved on to 3, the sunspots. These are also a bit important. Here I just wanted to put a picture. Here I just wanted to put a picture of the solar flare so you guys can see how it actually is. So sunspots are like the coolest spots on the sun where there's no more energy left in the areas. Then it cools and turns into a spot, and the place is like 6 times cooler than the real surface. Like the real surface has a lot of energy than a place that has no more energy or uses up all the energy. The radiative zone gives a flare or makes a solar flare. So this is somewhat related to the radiative zone, because now we're going to talk about sunspots, the most less dense, less hottest. It makes a spot on the sun like this, like a very dark spot. Not like ice cold. It's going to be like, we can all say it's good enough to not make us survive. Like as soon as you stand on a sunspot, if you have the right energy, I mean, and like the right spacesuit and everything, you can stay there for a while, but not that long. It's not like that cold or anything. It's just one place that's out of all the other cold places. It's like the last place the sun can get cold. So yeah, that's the sunspot. And one side of the sun that's getting so dense and it just can't hold it in, the radiative zone lets out a hole, and then solar flare, boom. And yes, these are the things, they're not related, but they do have something to do with each other. One spot so dense it explodes out of energy. One spot so less dense it just starts cooling. And if you guys have any questions about the sunspot, if the sun is lower mass and it doesn't really have that much energy, the sunspots can get bigger and cooler. But if the sun had massive energy and is so huge, like probably 12 times bigger than our sun, it could be able to heat up sunspots or just leave them there and forget about it. But the sunspots don't really make up a difference in the sun because there are a lot of spots in our sun coming up. So yeah, that's a sunspot, that's solar flare. And oh wait, this is the last one. Last slide for us today. I put a picture of the core and everything else so we can just summarize it. The sun's core is an ultimate source of all the plasma and heat, and the light, and also the hottest thing in the entire solar system. And now this will be a mind-blowing thing, but the core is not solid. The core is not solid. Clear up all your confusion. The core is not solid, guys. Yes. Now, I thought when I first studied this, I thought the core was going to be some iron, metal, and like, okay. But now when I actually find out what the core is, I was mind blown. It's not solid, but it keeps an entire beast together. So let's continue. The entire session, now we're going to talk about the core of the ultimate beast, the sun. So the core is the main thing that parts the sun rely on when they run on the heat, light, and energy. So this is going to be a big part we're going to talk about. The sun doesn't run on, like, at the start of this video, you guys meant just saying, where is all this fuel coming from? How is it letting go? How is it taking in? How is it recycling? And how is it pushing? This is a very important question that you guys all must know before you actually start, like, knowing about the sun. So the energy comes all from the core. The core is the core, the base of all the layers on the sun, and also the creator of the ultimate beast, this huge fireball. And it's made of entire plasma, like really high in energy plasma. And yeah, that's the sun's core. And I know that was very short. It felt like it was pretty long, but that's the end for that topic today. So we all know, as I'm gonna go back to the front, we all know that the sun is not like any other planet. It's huge. It has it's like overpowered, I should say, and it is very, very rare. So guys, I'm telling you, we're lucky. The solar system was born with a perfectly good sun for our solar system. If it was too big, too bad. Too small, too bad. This sun was perfectly at the medium size. So we should enjoy it until it lasts. And yeah, as long as the sun has its fuel, we're all happy. We get light, we get heat. The most thing, we're alive. And yeah, but also always remember, guys, the earth also has fuel, and we should also not waste that. I'll be talking that on my third video about the earth, but don't worry about that. And yeah, this is our video end for today, and please subscribe and give a huge thumbs up, and see you in our next video. Bye.